Hello, everyone, and thank you for being here and listening to my presentation on what Emiquon has taught us, a look into waterfowl hunting opportunity across the Illinois River Valley. I also wanted to quickly shout out to the other Forbes Biological Station staff for helping me out with this project, Abby, Liz, Andy, Chelsea, Josh, Auriel. I couldn't have done it without you, but I also wanted to provide a little bit of an introduction for myself. My name is Therin Bradshaw, and I'm a waterfowl ecologist at the Forbes Biological Station. And I have known Emiquon or had a relationship with Emiquon since 2013. This is actually a picture of me in my first time at Emiquon, and now I get to conduct research at Emiquon on a regular basis, and that has been awesome. With all of the experiences I have gained from the research I have helped out with in the past, I feel like I have the confidence to state that I, Therin Bradshaw, want more waterfowl. I think most folks participating in this symposium would agree, and so I'll go ahead and change it to we want more waterfowl. Now, this is a general goal for everyone in the waterfowl community, whether it's land managers, researchers, hunters, birders, etc., to provide for and host for more migrating waterfowl in our area. So what do we know about getting more birds or providing for more birds in our area? I would argue that we know quite a bit. If we start with our current number of birds and we provide more food on the landscape, more birds will come. We know that if we increase the surface area across the landscape, we can host more birds. And we know that when birds are provided with sanctuary, they use it a lot, especially during the hunting season. When we provide resources like these, food, water, and safety, we are providing habitat. And we know by increasing habitat or improving habitat, we are providing for more birds. Another important part of our management for waterfowl includes that long-standing goal of increasing hunter opportunity to then increase conservation funds from tax revenues that help establish new habitat and improve existing habitat, thus providing for more birds and potentially increase hunter opportunity to feed that cycle. Now, in order to monitor the changes in hunter opportunity or monitor how birds are interacting with hunters across our area, we need a way to quantify changes in hunter opportunity on a landscape scale. So folks might be asking the question, how do we measure hunter opportunity? Well, there are a good number of different options, but our suggested method to monitor and assess hunter opportunity across the landscape is with autonomous recording units, or ARUs. These devices record audio from the environment and are frequently used in wildlife studies with birds, bats, and frogs, anything that produce a unique audio signal or call. And those recordings are processed by running an automated detector through audio software like Raven Pro. But we plan on using this method of obtaining recordings from the landscape and processing audio files through audio software to detect shotgun blasts. Now, we believe that the number of gunshots detected is a good way to monitor hunter opportunity, not necessarily success and not necessarily participation, but measuring hunter opportunity. In theory, when we detect more gunshots for a given ARU, there was more opportunity to actively participate in hunting in that area, and that there was more hunter disturbance or loud noises made in that given area. Now, to detect the number of gunshots in a recording from an ARU, we used Raven Pro software using their band-limited energy detector that acts as a filter and flags potential shotgun blasts, but also includes other noises such as folks slamming car doors, folks loading and unloading boats, and more natural sounds such as woodpeckers on trees. After the detector has flagged loud noises, including gunshots, we had to verify each of those flagged instances. So you can see to the left here is an example of what a shotgun blast, or in this case, 2 shotgun blasts look like. You can see that there is a strong left side signal or initial signal, and then that signal decays rapidly over time. Now, in our preparation for our study to assess hunter opportunity across the landscape, we still had multiple questions, mainly, how well do these ARUs actually work? We wanted to test our questions, and we obtained questions we had questions such as, what range of distances can we record and detect shotgun blasts? And we also wanted to know, what environmental conditions can we record and detect gunshot blasts? For instance, how much is too much wind before the audio quality diminishes? and how much sound does rain and other precipitation influence the audio detector. So with the help of the folks at the Emiquon Preserve, we were able to conduct a small case study to answer some of these questions that we had. Our big question we had was distance. So how far can an ARU listen or record shotgun blasts? And in turn, how far do ARUs need to be spaced from each other to minimize overlap between two units, but maximize coverage across the landscape? With the permission of the Emiquon Preserve, we were able to encompass the wetland of Emiquon with 12 ARUs shown on the map in red. Their positions ranged from 1,000 meters apart from the closest units to 8,000 meters apart from the furthest units. So we were able to test that overlap theory of at what point are those ARUs actually overlapping with each other. Excuse me. Here is a map that demonstrated our anticipated overlap across units. These are 1,200 meter buffers, which is within the range of suggested distances ARUs can record and detect gunshots based on previous research elsewhere. We really liked being able to have areas of greater overlap in the southern areas of Emiquon and to have some potential gaps where the ARUs are missing gunshots in the north. But with all of the ARUs set at each of the little blue points, we fired 4 shotgun blasts. Actually, it says most locations, and we put that in there because on the furthest west transect, we did not shoot west towards the very, very frequently traveled road adjacent to Emiquon. So on those transects to the far west, we did not fire to the west. We only fired north, east, and south. But at each location, we took wind measurements and we had recorded the time of each shotgun blast as we fired them. And I can tell you that I had a lot of fun conducting this study. So, not necessarily in conclusion, but I can tell you that Emiquon has taught us a lot. There are factors that are influencing ARU's ability to record and for the software to detect those gunshots from those recording. First up is wind. As you can see here, I have pulled 2 example units, one in the south in green and one in the north in red. And it is our belief that, as you can see, there is significantly less detections on the southern unit, where it reached maybe halfway up the wetland of Emiquon, whereas the northern unit in red detected gunshots fired throughout the wetland of Emiquon. And we believe, even though the wind was very limiting that day, we do think that wind was still carrying that noise up to those northern units. Now, we are also interested in seeing how the shot direction, or the direction in which the shot was fired, had an influence on gunshots. And if you look closely at the maps, those directions mean that there was a positive detection for the shot that was fired in that direction. So you can see some points there's no shots. That means that I could verify that a shot did happen at that point, but I could not tell you if it was north, south, east, or west. If there is only one line and it's pointing south, that means that the southern shot was heard during that time, etc. But you can see that on the green there and to the south, there's a good cluster of shots where the ARU was able to detect all shots that were fired, versus those spots to the north had only a few of those shots detected and not a detection for the shot facing away from the ARU. So we figured out that there was quite an influence of how our ARUs were performance just based on shotgun direction. But we also believe that habitat structure is also influencing how sound travels. As you can see, you can tell the difference between the open water and where the vegetation was growing, and we believe that the sound is traveling more efficiently or further across open water. But we did not take any specific measurements on that during that trial, but we believe that is what's happening as well. But I compiled some of our raw data and made a little animation to visualize what we were seeing. And as you can see, it was less uniform than we expected. That, depending on where the shot was fired, sometimes resulted in different units detecting the gunshots. So if you follow that orange dot, we actually had two teams going. We had a team on a boat, and we had a team on ATV firing shots. And you can see at a given location, those green dots, when they light up, that means that those units or those ARUs were able to detect gunshots from those locations. So we were able to plug in all of our data into a predicting model, and it ended up predicting detection probability on the y-axis as the distance increased on the x-axis. And so we used, and this model was using the verified gunshots that the detector did successfully detect gunshots versus our known misses from when we knew a gunshot had occurred, but our detector did not detect those. And you can see that we got a nice little sloped line here. And what we can pull from this predicting model is kind of an area range of confidence intervals for our detector, our audio detector. So if we are interested in making sure that our detection probability stayed above 70%, then we would make sure that our units were not spaced out more than the 1,250 meters indicated in our predictor. But realistically, we are okay with it dipping below 70%, and so we're using ranges closer to 1,600 meters or a mile. But with all of this information obtained from Emiquon, or that small Emiquon case study, we now have a better understanding of the range that these ARUs can record and detect shotgun blasts, thus informing us on how dense these units need to be spaced across the landscape, or in our case, the Illinois River Valley. So what you're looking at now is the ARU placement we decided on for the fall of last year using the data collected during the Emiquon case study. We're pretty satisfied with our spread that we currently have to maximize coverage and minimize overlap, but we are going to plant a few additional units across the landscape for next year. But with this ARU survey method, we are now able to tally and total the number of detections per unit per day and make some pretty nice heat maps of our survey area like this one. If you look closely, or the colors, oranges and reds are between 200 and 1,200 detections in a day. Greens are around 50 to 150 detections in a day, whereas the blue colors are between 0 and 30 shots detected. Now, an important message to share with you all is that since our ARUs do not detect 100% of gunshots, these maps more represent trends rather than exact numbers. So we can state that some areas had more detections versus others, and so we can see which areas were our hot spots on a given day. And so when you put all of these maps together and animate them through time, you get a very flashy little video of showing how hunter opportunity is changing through the course of time. Now, we're very excited about where this hunter opportunity project is going. We are actually putting out GPS marked birds during the same time we're collecting ARU data, with the hopes to see how birds are moving across the landscape in relation to hunter opportunity. But overall, I wanted to again thank the Emiquon Preserve staff for allowing us to conduct this case study at Emiquon, and it was absolutely instrumental for us to understand how the ARUs are performing across the landscape. And there were a lot of other folks too I would like to thank as well for helping in this project in one way or another. But with that, I would go ahead and pause, and I'd be willing to take any questions you guys may have. Thank you very much for listening.